All right, so hi everyone. This is Mr. Garner, one of the Algebra 2 Pre-AP teachers, and if you're listening to this, you're probably wanting to get a refresher on factoring so you can kind of clean up some of the issues from the factoring drill. Keep in mind that your factoring drill is only 1/3 of a quiz grade, so it's not a huge deal, but why not make it better? So we're going to go ahead and refresh or revisit factoring. And remember what a factor is. It's just a value that is multiplied with another value, okay? Normally, if you want to do 2 as a factor times 3 as another factor, that multiplies to 6, okay? What we do when we factor something, either a number or some kind of an expression or something algebraic, instead of multiplying some things together to get a result, we're going to go to the result and split it into its component factors. So for example, if I just give you a 6 and you look at it and you say, oh, well, 2 goes into 6. Well, that's right. 2 is one of the factors that'll multiply to 6. And if you want to figure out what that other factor is that multiplies with the 2 to give you 6, you can just divide the 2 back into the 6, and you're going to get a 3. So basically what that's saying is that 2 times 3 are the 2 factors that multiply to 6. All right, so now 6 is factored. Keeping in mind that 6 can factor other ways. You can have a 2 times 3, or you can have a 6 times 1. Okay, so you have a little freedom when it comes to that. When you do the kind of things that we did when we did the factor drill, what we're looking at here are some polynomials, more than one monomial, and they basically, almost all of them, have some factors that are in common between the terms, okay? So what I'm going to do here is to try to work out 2 or 3 of these. I don't want to do the whole thing for you because that's not going to get you the skill. The skill is going to come when you understand how the factoring works, okay? So maybe we'll look at like the first one, for example. So if you look at this 12y and you look at the 16, you can say to yourself, well, between those two things, a 12 and a 16, of course there is no y on the second term, but between the 12 and the 16, they're both divisible by 2, and that's fine. So if you factor out a 2, then you can just divide that 2 back in to see what's left over. And that'll give you what? 2 goes into 12, leaving 6, so 6y. And then 2 goes into 16, leaving 8. And so you can walk away and think that that's perfectly fine. Except if you look back at what you already factored, that has still factors in common because 2 will go into 6 and 2 will go into 8. So while you factored that, you did not factor it into what the goal is. The goal here is to get the product of your greatest common factor times a prime polynomial. And the thing that makes a polynomial prime is that you can't factor it anymore, at least not over the set of integers, okay? So this is not prime, and if you're in my class, you see this NP show up all the time, and that's just shorthand for you left some factors in there that should have come out, all right? So we're going to start over and look at that problem, and yeah. So while 2 goes into both, doesn't 4 also go into both? So we could factor out a 4, but let's see if there's anything higher than that. Does a 6 go into both of those? Well, it goes into the 12, but not into the 16. So the 6 is out. Does 8 go into both? Well, 8 will go into 16, but it won't go into 12, not evenly. So 8 is out. So I think you can probably see that each one of those two terms has a 4 in common. Now again, there's only a y in this first term and not in the second term. So we can't take a y out because they don't share a y. So we took a 4 out. So what's left over? Well, to figure out what's left over, just divide each side by 4. Well, 4 goes into 12 3 times, so that'll be 3y, and 4 goes into 16, leaving 4. And there's a minus in between. That doesn't change. So then you kind of take a step back and you look at it and you say to yourself, okay, is there a factor left over between 3 and 4 that I can take out? And other than the number 1, that's it. So you're not going to be able to do anything more. This is going to be a greatest common factor. If I can make that correct, GCF. And this 3y minus 4 is a prime polynomial. Okay, good with that? All right, so that's done. So that's one you don't have to do. All right, if you look at number 3, for example, if you examine this term, it's got a 13 and an A, and this has a negative 20 and a B. Well, 13 is a prime number. In other words, it only factors into itself and 1. So does 13 also go into 20? No, because, no, it's not going to go in. And this has an A and this has a B, which means there are no variables in common. So basically, I can't figure out anything that'll go into both terms other than the number 1. And that's not really considered factoring. So this is just going to be prime. And prime just tells you, I tried to factor it, there are no factors in common, so I couldn't factor it. It's unfactorable, at least over the set of integers. All right? So then you have that going for you. All right, so we did this one, number 1, and we did this one, number 2. I'm just going to do one more, and then you get to fix up the rest. And the last one I'm going to do is number 9. Okay? And if you look at number 9, they do have a lot of things in common. If you look at the big number coefficients, they're both divisible by 5. Okay? And I'm not sure we can go any higher than that, because while 20 can factor into 10 and 2, 10 does not go into 15, nor does 2, not evenly. Okay? So we can at least figure we can take out a 5 from both. Okay? And then we'll just figure out what's left over later. Now the trick here is, what about the x's? What about them? All right, look at this first term, for example. That has x to the 6. That means it has 6 factors of x. 1, 2, 3, 4, 5, 6. And if you look over here, this 15x squared has 2 factors of x. Okay? So how many do they have in common? Well, this one has 2, and this one has at least 2. All right? So it makes sense that we can pull out at most between the 2 an x squared. And that's going to be the rule that you follow whenever you factor anything with an exponent like that. You want to grab the exponent that's the smallest, and that will be the greatest, the one that's in common to both, because at least each one of these has, well, let me put it to you this way, each one of these has at least 2 factors of x. Okay? It wouldn't make any sense to go any higher than 2, because there aren't any more than 2 factors in that second term. Okay? So then that begs the question, what's going to be left over in my prime polynomial? Well, just let's go ahead and divide this out, the 5x squared, just to see what's left over. All right? Well, x squared and x squared cancel to 1. 5 and 15 cancel to 3. So 3 times 1 over 1 times 1, that's going to be a 3. The plus stays, so let's look over here. Remember, when you're dividing like this, you subtract exponents. So x squared goes into x to the 6. 6 minus 2 is x to the 4th. 5 goes into 20, leaving 4. So it's 4x to the 4th plus 3. And if you look back at it to make sure it's all done and complete, between this term and this term here, I don't see any common factors left over that I can pull out. So the way to make sure you did it right is just to, and you can do this mentally, is to go ahead and re-multiply to see if you can go back to what you started with, because you've got to include everything that will make that multiplication restore what you started with. So 5 times 4 is 20. X squared times x to the 4th, you add your exponents, that's x to the 6th, that checks out. And then 5 times 3 is 15. And you just bring the x squared over with it. And that looks pretty much exactly what I started with. Okay? So that is your greatest common factor times the prime polynomial. All right, all the rest of these work exactly the same. Now some of the kids for number 10 realized that once you take out your greatest common factor, that what was left over could also factor, but I don't care about that. We don't really need to worry about whether or not that can be factored more. Just go ahead and do the same thing, greatest common factor times prime polynomial. Okay, so let's see how it goes. Clean this up, get your corrections turned in, get your grade fixed up, and hopefully this was a good lesson to help you. Okay, thanks a lot for listening. Bye.